Hello everyone, welcome back to my YouTube channel. This is Filipino Explaining. So let's look at diagonalization and eigenvalues in this video. Okay, diagonalization and eigenvalues theorem. If A is equals to P D P raised by -1, then A raised power K is equals to P D raised power K P raised by -1 for each K is equals to 1, 2, dot, dot, dot. So let's look at eigenvalues and eigenvectors. Eigenvectors, eigenvalues and eigenvectors. So one of the most important things that you have to know under eigenvalues and eigenvectors is that diagonalizing a matrix entails calculating a certain numbers associated with the matrix. If, for example, if A is an n by n matrix, then let's let A to be an n by n matrix. A number lambda is called an eigenvalue of A if A times x, that is ax, is equals to lambda times x, that is lambda x. For some column, x is not equals to 0. In this case, x is called an eigenvector of A corresponding to the eigenvalue lambda. I'm saying that x is this x is an eigenvector. This is eigenvector. Also this x is eigenvector of A corresponding to the eigenvalue lambda. This is the eigenvalue. This vector, and this is value. Are we there? This vector to the eigenvalue lambda, or a lambda eigenvector for short. For example, let's look at one example here. If A is equals to 3, 5, 1, -1, A is a matrix, and x is equals to 5, 1. These are column matrix. These are 2 by 2 matrix. Then Ax is equals to what? Let's look at this. Let's find Ax. So solution. We have said that we use this, that Ax is equals to lambda x, where A is this matrix, x is this row matrix, not row matrix but column matrix, sorry. This x is column matrix. Then we have said that this lambda is an eigenvalue. Are we there? So we are saying that Ax is equals to lambda x. So we take this A, we put it here. We just substitute 3, 5, 1, negative 1. We multiply by x. This is x, 5, 5, 1. Here, we use that rule for multiplication of matrices, rule 7. This one, we take this 5, we multiply by 3, we add 5 times 1. Are you there? So we are saying here is 5 times 3, 5 times 3 plus 5 times 3 plus, remember rule 7, plus 5 times 1. This 5 times 1. Are we there? The second row downwards. This 5 times 1, 5 times 1 plus 1 times negative 1. 5 times 1 plus 1 negative times negative 1. 1 times negative 1. Is still a matrix. This gives us remember this one is ax. This one is ax. So this 5 times 3 of course is 15. 5 times 1 is 5. 5 times 1 again is 5. Then 1 times negative 1 is negative 1. Hope you understand. So this gives us 20, and 5 plus negative 1 is 5 minus 1, that is 4. So you can say, and therefore our ax is equals to 24. But now we want to express ax in terms of lambda x. This we have to find this lambda. Are we getting? We have a, we have x, so we want this lambda first. Are we there? We have said that ax, this ax is equals to lambda x. So this 20 over, not 20 over, but this 24, 24, which is our result, our matrix after you have gotten the product of a and x, that is 24 is equals to lambda x, is equal to lambda x. But what is our x? Our x is 5, 1. Our x is 5, 1 from the question. 5, 5, 1. So here, to get the value of x, of lambda, sorry, you can just take this lambda, you multiply by each of these elements in this row column matrix. Are you there? So it is 24 is equals to, this time this is 5 lambda, this time this is lambda. Are we there? So to get the value of lambda, you can either take this or this. So we can take the first one and say 20 is equals to 5 lambda over 5 over 5. This gives us lambda as 4. Or we can also use the lower one from the second row. Say 4. This 4 is equals to lambda. So our lambda is equals to 4. So we can say that ax, this ax is equals to lambda is 4. Are we there? Lambda is 4 is equals to 4 is equals to 4x. So that we can say that lambda is equals to 4 is an eigenvalue of A with the corresponding eigenvector x. Are we there? Lambda, which is equals to 4, is an eigenvalue of A with the corresponding eigenvector x. Are we there? And at that point, we are through with that. We are through with that eigenvalues and eigenvectors and how to find that lambda. We are through. We can see how we have moved, how we have calculated, how we have gone up to the end. Thank you so much for watching. Thank you so much. please kindly, can say kindly, make sure you do subscribe to my YouTube channel to support my efforts. If you are seeing me or listening to me for the first time, or you are new to my channel, or have been seeing me, you have been listening to me, but you have not yet subscribed, kindly do so to support my effort. Thank you so much. See you next time. Bye bye.